So LeetCode 1781, sum of beauty of all substrings. So the beauty of a string is the difference between the most frequent character and the least frequent characters counts. So for example, the beauty of this is 3 because you have 3 A's minus 1 because you only have 1 B, which is the least frequent character, and that's equal to 2. And now you're given a string S and you need to return the sum of beauty of all of its substrings. Okay, so the way we're going to solve this is we're going to loop through all of the substrings and add to our result the beauty of the substring, and then we're going to return the result. So here's how we're going to do that. So first of all, we split our string with nothing. So now we have an array of characters, and we map that array of characters to their character code normalized with the character code of the smallest letter in our alphabet. So we only have lowercase English letters, so the smallest letter is A. And so now we have just an array of character codes. Perfect. Now we're also going to have our result, which is going to be the sum of beauty of all of the substrings. And then we're going to later on return this variable. So this is going to be our return variable. And now we also need a count array that basically counts the character code instances, so the frequency of a given character code. And the English alphabet length is only 26. So we just need 26 cells and we fill them with 0. So this is going to be our counting data structure. Perfect. Now we can do our 2 nested loops so that we get all of the substrings of S. And keep in mind, this can only be done because the constraints are pretty low. So we only have 500 at most length. Perfect. So now we have our 2 nested loops. The first one, just a normal for loop. And then for every outer loop, we always want to fill our counts array back with the original value. So we always want to reset to 0. And now what we can do is we can have our nested loop that goes through all of the characters in our substring. And what it needs to do is it needs to update the count of the current character and then update the result with the beauty of the current substring that we are looking at. Okay, so first of all, we increment the frequency, the count of the current character that we are looking at, and then we update the result with the beauty of the current substring that we are looking at. So we add to the result the difference between the maximum value of a frequency and the minimum value of a frequency. And here, a common mistake is to forget that here we actually need to filter the frequencies because we don't want this to always result in a 0. So for example, if you have a string ABCD or something like that, if you just keep the code like this, then the beauty would be calculated as 1. Because, for example, you have 0 characters of Z, of the letter Z. And so what you actually want to do is you want to calculate the minimum of the characters that appear at least once. So you want to filter this count, and you want to only have the characters that appear at least once. And you don't have to do that here because, of course, there is at least one that appears once. And so that's actually it. So I'll submit the solution to show you that it works. And the time complexity is O of n squared because you have 2 nested loops on the same array with 2 different indices. And you should also mention that there's also a factor of the length of the alphabet. So this max function here is looping through 26 cells. So truly this would be 26 times n times n. And the space complexity is just the space to store the string and the count array. So it's O of n, where n is the length of the string, plus O of k, where k is the length of the alphabet. So that's it from me today. Thank you for watching, and bye.